All right. So what does this break down to be, everyone? You have the negative 1 out here still. Those three terms break down to be x minus 3, x minus 8. Okay. All right, so do you know how to do that? Let's look at something else, maybe a little more challenging. Right? We like challenging problems, right? How about we do 5x to the 5th plus, let's see, 40x squared. Factor this. Right, so what's the first thing you see there? The first thing we do. DCF. Take your DCF out. See what you get. So what do you have? What's your next line going to read after you take out your GCF? So 5x squared was your GCF. You're left with x to the 3rd plus 8. That okay, everyone? All right, we done? Inside the parentheses, two terms. When you look at the two terms, you say, is that either a difference of squares, sum of cubes, difference of cubes? In this case, it's the sum of cubes. Right? This right here is a sum of cubes. Now, in case you don't have that formula in your brain or tattooed on your arm, let's write it down. If you have x cubed, well, I'll do it the way most books would do it. A cubed plus b cubed will always factor to be a plus b times a squared minus ab plus b squared. That is the formula for the sum of cubes. Does that look familiar? Okay. In our problem, the a is actually what? For us, a is what? X. And what is b for us? Careful. B is not 8. B is 2. Right? Because what we have to recognize is that x cubed plus 8 is actually x cubed plus 2 cubed. So your x is your a, and your 2 is your b. And then you just replace everything into the formula. Can I do that now? I have my 5x squared out front. I have now the formula. It's going to look like this. I'm just going to throw the sets of parentheses out there. It's kind of like a small parenthesis, then a big one. So what's the first thing in that formula? So it's the a plus b. For us, that's x plus 2. X plus 2. And then we have what? A squared. For us, that's x squared. Then minus a times b, which for us is x times 2, which is really 2x. We never write x2, right? We write 2x. And then finally, plus the b for us, which is 2, but squared, which would give us 4. 2 squared is 4. Right? Now, let's look at this result. Any questions on that? Are we done? Well, here's the thing. With those two things we just got right there, those two things came from the formula, didn't they? Okay, if those two things came from the formula, then it's guaranteed it does not factor anymore. Always, okay? So you might be looking at this second piece right here. You might be going, 3 terms, AC method. You might be thinking that, right? But it's guaranteed it will not factor if it came from that formula. See, those formulas always give you something like this at the end, but it will never break down. So we can stop here. You can try it yourself with your AC method. It's not going to work. You're never going to find the numbers that you need to make that work. So we stop here. That's our answer. Okay, so a little GCF there with the sum of cubes formula. Yes? Good question. When it's difference of cubes, I'll just write it down. Difference of cubes formula looks like this. A cubed minus B cubed equals A minus B. So that switches, right? Then you do A squared plus AB, and it's not minus, it's plus on the end. So the only things that switch are those two signs. The difference in the two formulas. Difference of key. I'm just looking at your homework assignment. Okay, let's do this one. I'm about to give you some work to do in class. Oh man, what happened? Okay, this example here. How about x to the 4th? And then how about minus 26x squared and then plus 25? Factor. So, do we have a GCF? No, right? No number goes in all those. There's no x's in all of them. There's 3 terms, right? So we can try an AC method. However, we need to be a little careful here because we don't have the standard form of an AC method. AC method, normally you use it whenever you have something like this, right? You have like a number in front of x squared plus a number in front of x and then plus some number by itself, right? We kind of have that, but it's not x squared. What do we have? X to the 4th. And then the middle term isn't x, it's x squared. So let's see how many of you saw the what's called U substitution for something like this. Let me show you something. I'm going to let U be equal to x squared. And where I'm getting that from is the middle term there, okay? Whatever that variable was. So what I'm doing is I'm just walking into this problem. I'm saying, hey, look, everyone, wherever you see an x squared, replace it with u, okay? Just trust me, that's what we're going to do. With me? Now let's see why that works. If I rewrite this problem, do you agree that x to the 4th is x squared squared? Yes? Minus 26, now I have that x squared, plus 25. So do you see now you got your x squared in 2 places now? See it? So would you mind now rewriting the problem in terms of u instead of x? So everywhere you see an x squared, go and replace it with a u now. And don't worry, we'll switch back at the very end. But for now, just switch your x squareds to u's. So how would this problem now read? U squared minus 26u plus 25. Now this looks more like the standard form for AC method, doesn't it? You've got a squared, and then in the middle you've got just the u and then a number by itself. So I'm going to do a very quick AC method. This is the way I've taught my class. I've got a 25 and a negative 26 here. the two numbers that multiply to be positive 25 but add up to be negative 26 are negative 1 and negative 25. Again, if AC method is something that you're really still confused on, don't take what I'm doing here as a substitute for you going to the lab and getting some help on this, okay? Then you go through your step of grouping or whatever it is, however you know or were taught to go from that to the next step. And you eventually, so I should probably put ... here. ... meaning whatever steps you need, you take it to the point where it's u minus 1, u minus 25. Right? Now you switch back. That's right. Now, because the problem was originally in terms of x, and now our answer is in terms of u. So we've got to switch back now. So everywhere you see a u now, replace it back with your x squared. All right? That u and that u get replaced back. So it's going to be x squared minus 1, x squared minus 25. And both of those are what? Difference of squares. So the first one turns into something and the second one turns into something. X plus 1, x minus 1, x plus 5, x minus 5. And we are done with that. Last one, promise. And then you're going to get to, I'm going to let you actually start on some of your homework. I'm going to put some of the problems on the board in case you don't have your book. And you can at least get started on your homework. But I'm going to count it as a participation quiz grade today. All right? So for the last, whatever, 25 minutes. Is that how much time we have? Yeah, something like that. Okay, but let me show you one last example. I'll start a new page. Last example, I would like for us to factor x squared minus 14x minus 36. GCF? No. 3 terms? So you do an AC method. I'm going to multiply the number in the front, which is a 1, times the number in the back, which is negative 36. And then I'm going to look at the number in front of x, which is negative 14. And I'm going to try and come up with 2 numbers that multiply to be negative 36 but add up to be negative 14. What numbers multiply to be negative 36? Let's see, negative 1 and 36, 1 and 36. Those don't work because those don't add up to be negative 14. 2 and 18, sorry, negative 2 and 18, is that correct? Positive 2 and negative 18? Oh, close, but that doesn't work either, right? 3, negative 3 and 12 and positive 3 and negative 12. Those don't work. 4, negative 4 and 9, 4 and negative 9. Nope. 5, doesn't go in there. 6, 6 and 6, or negative 6 and 6. That's not going to work. 7, 8, 9. We've exhausted all the numbers. So what do we say when we can't factor it? We call it prime. Okay? That's our answer. It's prime. That just means it doesn't break down. We can't break it down. All right? I just wanted to make sure, because if you're doing your homework and you're like checking your answer in the back of the book, it says prime. That's what's happening. Okay? Now, there's a difference, okay? If you have a problem that does break down, like this one, okay, and it does break down to be this, but you can't figure that out, that doesn't mean it's prime. Okay, because if it does factor, it's not prime. If it doesn't factor, then it's prime. All right, let me put down here what I want you to do for homework. Let's see, does our schedule have the homework? I don't think it does, right? No. Okay, here's what I'd like for you to do for homework. It's going to come off page 42. It's going to be problem 7, 9. I'm going to put a little highlight around 9 because I didn't do 1 like 9 in class, so you might have a little trouble with that. Let's see how you do. 11, 13. You know what? I should have just said 7 through 23 odd. That's what I should have said. That's really what that was going to be. And then 27 through 47 odd. This is a lot of work right here, okay? There's a lot of factoring in there. Here's the good news. In the first 23 problems, it tells you what you're supposed to do. Like for number 23, right above it in bold, it says use substitution. So it's telling you to do what I did in class, right? Problem 17 says difference of perfect squares. So you know, looking at it, it's supposed to be that. So that's kind of leading you. Once you get to 27 through 47, it does not prompt you with what it is, and you're just supposed to go at it. So numbers 27 through 47 are more like what you would see on a test, because I'll never tell you factor by using difference of squares. I'll just say factor. All right, so maybe a good place to start for today for your in-class quiz for the next 20 minutes would be, how about we do this one? I'll write them down and then I'll put the problem here in case you don't have a book. All of these are factor problems. I'm just picking some random ones here. 4s squared minus 25. Hey, I just realized, well, no, I like that. No, I'll let you play with that. I think that's good for the first section. Out of the second section, I'm just going to give you one problem to mess with. This is number 33. Negative 9r plus r squared plus 18. Be careful on 33. It's not given to you in the standard way you normally see things. You might have to do a little something first before you start working that problem out. All right, good? I'm going to stop the video.